For everyone who's joining, we're just giving it a few more minutes for people to filter in. All right, we'll probably get started with just a brief overview of what iGuide is and iGuide VCO. So if you're new, iGuide is the Institute for Geospatial Understanding through an Integrative Discovery Environment. And we do these virtual consulting office talks weekly, bi-weekly throughout the year, just showing off different research innovations, educational tools like curriculum, just a wide variety of stuff. If you're interested, all of that information is on the iGuide VCO webpage. So today we have a transformer-based multitask deep learning model for urban livability evaluation by fusing remote sensing and textual geospatial data, which will be presented by Wen Zhou. Next week, we do not have a VCO because we have the iGuide Forum in Chicago. So if you're in the Chicago area, it is co-located with the Sustainability Research Congress. Let me pull up that. I always forget the exact name. The Sustainability Research and Innovation Congress. So it'll be a great conference for learning more about iGuide, but just sustainability in general. And it's in a beautiful area of Chicago. The week after that, June 25th, we're going to have open source spatiotemporal geovisual analytics with CyberGS Viz, a COVID-19 case study, which will be presented by Soo-Yun Han from Texas State University. And then we're still booking for July, but we do have July 30th set is going to be Jeff Boeing, the developer of OSMNX, is going to be talking about the science of urban networks. So hope to see you next week in Chicago, and if not, hopefully at some of the upcoming VCOs. But without further ado, I will pass it over to Dr. Zhou.
Yes. I'll share my slide first. Not this one. Can you see my slide now? Yeah. Hello, everyone. Today, I will show you one of my paper. It's a under review paper about urban livability evaluation based upon fusing remote sensing and geospatial texture data through multimodal deep learning. The concept, sorry. Yeah, the concept of livability is multifaceted with individual perspectives shaping its definition. But in general, livability refers the degree to which a place is good for living. So for the urban researcher and the government, one of their important work is to develop the livable city. So how to develop the livable city? A livable city will also coincide with the Sustainable Development Goal 11. It is creating inclusive, safe, resilient, and sustainable urban environment and settlement. 3 steps need to be taken for build livable city. The first is evaluate the urban livability. It means first we need to acquire the livability inequality among this city and then to give a targeted solutions to improve the livability. So the second step is to analyze what's the influence factors. And then the last one is to improve the urban livability targetedly. Sorry. Currently, for the livability evaluation, the mainstream method is based on statistic. It means, firstly, it will extract different indicators from different data sources and also involve the indicators extracted from the questionnaire survey. So this type of method is really time consuming, costly, and update slowly. Currently, with the development of deep learning, it provides a new way to evaluate. Deep learning method is much more efficient, economic, and can update quickly. Currently, to the best of my knowledge, the latest paper that using deep learning method to evaluate livability is proposed in 2023. In this paper, it used the CN method to evaluate livability based on satellite imageries only. So the limitation is obviously that it only uses single modalities, and single modality can only provide limited information. So it has restricted the livability evaluation accuracy. So here we proposed our research question, how to evaluate livability based on fusing multiple geospatial data sources, because we know more data sources can provide more information. Our study area lies in the Netherlands. We have selected 13 cities for the training, validation, and testing. Here's the distribution of those cities. For those 3 yellow cities, we have used them for the test. And for other left 9 cities, we have used them for the training and validation. In general, we have selected 29,000 samples for training and 9,000 samples for validation and 13,000 samples for the test. We can say our data set is really big and sufficient to train the model. The ground truth is come from the Netherlands government, their project of the Livability project. And here here I'll show you the sample of the city of Amsterdam. Here, this city, we can say that this image shows the overall livability score in this city with the much deep blue, much higher livability, and much deep red, the lower the livability. So also we can say that the samples in these cities has been also divided into the training and the validation. And we have used the grid as our basic analysis units. In this left barometer project, 47 environmental characteristics has been selected and to evaluate the urban livability. And those characteristics can be categorized into 5 domains. They are physical environment domain, nuisance and secure and safety domain, social coherence domain, housing availability domain, and amenity domain. And according to the reference paper, we found that many researchers use different types of modalities to evaluate different livability domain, such as the remote sensing imageries and point of interest data, and the nightlight remote sensing imageries data has been used to evaluate the physical environment domain. Also, for the nuisance and the safety domain, the nightlight satellite imageries and the remote sensing imageries has been used to evaluate it. Also, the nightlight satellite imageries can reflect the social coherence information, and the remote sensing imageries, digital surface model, point of interest data, and nightlight satellite imageries has been used to reflect the reflect the housing availability domain. Also, the satellite imageries and the point of interest data can reflect the amenity domain. So in our research, we have combined all those 4 types of modalities to evaluate the urban livability. Not only the overall livability domain, but also these 5 different types of livability domains. Here I will show you the workflow of the dataset generation. As I have said, that our livability, we will evaluate the overall livability score. Admit me a moment. Yeah. As I have said, that we will evaluate the overall livability score and also its 5 domain scores. And in the Dutch government's project, the basic analysis unit of the livability is a grid with a 100 meters multiply 100 meters spatial extent. But even though the livability has been given to this small grid, when they evaluate the livability situation of this grid, they consider not only the information inside of this grid, but also the its surrounding spatial extent. The surrounding spatial extent is a 500 meters multiply 500 meters spatial extent. So we need to align the 4 types of modalities with the livability grid, right? So how do we align them? We have used the analysis spatial extent to capture its corresponding satellite imageries, night satellite imageries, and the point of interest data. Because the spatial resolution of the satellite imageries, night light satellite imageries, and the point of interest of these 2 image modalities is not too high. So finally, we have acquired the patch size of 250 pixels multiply 250 pixels for the satellite imageries, and 50 multiply 50 pixels for the nightlight imageries. And for the point of interest data, all the points inside of the analysis spatial extent will be adding to our JSON file. For the digital surface model, it has a much higher spatial resolution with a 0.5 meters per pixel. And we'd like to use this modality to reflect the more detailed building and the surrounding information in a much more detailed grid. So we have only captured the DSM modality inside of the grid. Here I'll show you how we organized our dataset. For each livability sample, we will give it a ID, and then we will record the remote sensing image's name, the digital surface image's name, the nightlight remote sensing image's name, and also the 6th livability index, including the overall livability and the 5 domain scores. And for the PUI data, we have recorded it in the text part. This page shows our transformer-based multitask multimodal regression network. In this network, we have extracted the image features from all those 3 image modalities using a pre-trained dense net, and we have extracted the text features from the PUI data using the pre-trained BERT network. And then those 4 types of modalities, the features of those 4 types of modalities being concat, and then input into the transformer encoder. And finally, through a linear layer, we get the regression results. In this network, we have used a multitask mean square error loss function, where the n is the number of the sample, the t is the number of the task. Here, I will show you our experimental results. We have not only using the four modalities to regress the livability, but also using other different modality combinations. Here, we can say that from the overall livability score, we can say that when we using four modalities, we have used the two indicators to evaluate the performance. They are RMSE and Pearson R value. For the RMSE, the smaller the RMSE, the better the model performs. For the R value, it's used to reflect the linear correlation between the ground truth and the predicted value. So the higher the R value means they have a higher linear correlation. From the left figure shows the RMSE result of the test dataset. We can say that when we're using four modalities, no matter on the overall livability score or the 5 domain scores, it acquired the smallest RMSE. And also the same for the R value. When we're using four modalities, it acquired a higher R value than other modality combination. So it shows the necessary of combine those four modalities to evaluate the urban livability. And it also shows all those four modalities contributes to the urban livability evaluation. Here we will compare the difference between using other modality combination and between using other modality combination and using four modalities. This is the difference between them. We can say that from this table, we can show the information contribute the information richness and the information gain of different modalities. Because if a modality contains more, if a modality contains more rich information, when only using these modalities, it can acquire higher regression results, right? So when we're only using a single modalities to regress urban livability, we found the RMSE. This is the decrease of the RMSE, right? If a RMSE decrease less, means compared to the result only using four modalities, the decrease of the model's performance also decrease less, right? So when we're only using the RS modalities, from the livability score, we can say that the decrease on RS is smaller than the decrease on DSM, and also smaller than that only using the night light satellite imageries. So it reflects the information richness on the livability score. Is ordered by the RS, DSM, NLRS, and the PY. Why I haven't listed PY here? Because the model cannot be trained when only using the PY. So that's why we ordered those four modalities in this way. Also, for those 5 domain scores, the situation changed a little bit with the order of NLRS and DSM exchanged. Also, we can analyze the information gain of different modalities. The information gain means when we involve these modalities, it can introduce much more new information. So we can say that when we remove the satellite imageries, the RMSE decrease is the largest. So we would say that the information gain of the RS is the largest. and also followed by the NLRS, DSM, and the PY on the overall livability score. Also, this order also happened on the domain livability of the social coherence and housing availability domain. And for the domain of physical security and the amenities, the order changed to the NLRS, RS, DSM, and PY. So this also reflects that different modalities provide different information provide different information on different domain. And the information given on the NUI, the nuisance and the security, is ordered like RS, DSM, NLRS. Oh, I forgot the PY. Yes. Here, we also given the density scatter for test cities. This is the regression result when we using 4 modalities, and also the regression result on the overall livability. We can see that for all those 4 test cities, our regression result seems good, because the higher the brighter the color means the high density, and while the dark color means the low density. So we can say that most samples has been correctly predicted. And we also calculated the RMSE score of those 4 test cities. They are shown in this table. Here we also given the livability inequality map of the 4 test cities. The first column is the ground truth value, and the second column is the predicted livability inequality, and the last one is the difference between the predicted result and the ground truth result. We can say that in general, our method can effectively reflect the equality of livability situation inside of this city. And also, we found the model tend to underestimate the livability situation. The underestimate means the model tends to given the analysis unit a lower livability score than its actual livability score. And we found that for the city of Eindhoven, it means this row, the 66% samples has been underestimated, and while for Hengelo, it's 66.4%. And I'll also show you the map on other 2 test cities. We can say that the also 66.1% samples has been underestimated on the city of Dordrecht, and 54.4% on the city of Basel has been underestimated. In our research, we also compared our method with the state-of-the-art deep learning-based livability evaluation method, the research I mentioned in the previous slides. So we found that this research only using single modalities. So we have compared our method using 4 modalities with that research only using the satellite imageries. We found that except for the in general for the RMSE score, our proposed method performs better than the compared one, no matter on the overall livability and on its 5 domain scores. While for the R value, our except the nuisance and insecurity and housing availability, for other left livability index, our proposed method performs better too. Except this research, we also compared our method with the state-of-the-art multimodal multitask regression network. This one is proposed last year. It's a multimodal deep learning-based approach for the housing price prediction. Because this proposed network only supports the two types of modality inputs, one image modality and one text modality. So we have compared our method using two modalities with that method also using two modalities. We also found that except for the amenities, except for the RMSE amenities, our proposed method performs better than the compared one, no matter on the overall livability of 5 domain scores, and also no matter on the RMSE or on the R value. And we also, for the compared one, we also tested the performance on the multitask and the single task. The multitask here means we will predict overall livability and 5 domain livability scores simultaneously, while the single task means we will predict only one index at one time. We also found that when for the compared experiment, when using multitask strategies, the RMSE score is much smaller, means the model regress performs much better. Also, the R value is much bigger, means the multitask one performs better. So here we also compared the multitask prediction and single task prediction of our own research. We found that when we say all the samples of those 4 cities, we found that the RMSEO multitask prediction, it means the left one, for the livability, physical domain, nuisance and insecurity, social coherence, housing availability, and amenities, is lower. The RMSE is lower than that on the single task prediction. So it shows the multitask prediction performs better than the single task prediction. So here comes the question why the multitask prediction performs better than the single task prediction. There's 2 possible reasons. The first is simultaneous regress all indicators allowed for a better utilization of the shared features across tasks. And the second one is when different tasks are related, the multitask learning can effectively capture their relationship. And we also analyzed the correlation between different tasks. We found that tasks are correlated with others in different extent and in different way. With some tasks are positively positively related, like for the oh sorry, I should change this one. The WN means the housing availability. This is the word come from the Dutch word. Sorry. This means the housing availability is highly positively related to the social coherence, while for this is the amenities. For the amenities, it is highly negatively related to the social coherence. In our research, we also analyzed the attention that the model given to different modalities when evaluating the livability. The model will give a high attention to one type of modalities in 2 situations. The first is these modalities plays a crucial role in the regression progress, and the second is This modalities has a significant heterogeneity within it, so it requires the model to focus on and learn those internal differences. As we have analyzed in our previous slide, the information gain and information richness on overall livabilities are ordered like this. So we can say that the RS and the RS plays the most crucial role in the regression progress, while the PI plays a less significant role in the regression result. However, the model have given a highest attention to the PI. So the reason is come from the second way, that it shows the PI data contains a really significant heterogeneity inside of it. So the model need to pay a higher attention on it, even though it contributes less. So this is the conclusion of our research. We found that these four modalities can effectively reflect urban livability and its five domain schools. And our proposed network can effectively learn the features and the relationships between different modalities and capturing the cross-indicator correlation and shared information. The third is the contribution ranking of the livability score evaluation across four modalities. In general, is ordered by satellite imageries, night light satellite imageries, DSM data, DSM, and point of interest data. The last one is we tested that multitask learning outperforms the single task learning, and it is necessary to use the multitask learning. The contribution of this work is summarized like that. We have evaluated the livability directly from the multiple geospatial data sources. We have proposed a new deep learning network to learn the features of those four modalities and their relationships. And we explored the synergy between different modalities for the overall livability and its five domain schools. We have evaluated urban livability and five domain schools simultaneously and respectively, providing that multitask learning is more suitable for these types of evaluation research. This is the acknowledgement, and thank you. Any questions?
Feel free to put questions in the chat or unmute if you have any.
Let me see. No, no one asked in the chat. Yeah. Okay, if there's no questions, I will show you my notebook. Okay. I have proposed both the dataset and the code of this research on the iGuide platform. But currently, due to this paper has not been published, I have set it as the status of private. I will make it public when the paper has been accepted. So we will quickly go through the code. Yes. Here I have provided samples of using four modalities for the livability evaluation and only using three image modalities for the livability evaluation, and also we're only using one modalities for the image for the livability evaluation. Also, I have provided the code to calculate to the attention that model given to different modalities. Let's go to this one. This notebook shows how to use 4 modalities to evaluate the urban livability. Firstly, we need to set the GPU, and then here we have given the name of training file, validation file, and test file. We need to input required modules here. We can see that. And here we need to set the experiment hyperparameter and arguments. Yeah, that's how we set those hyperparameter. Here, we set do train, do validation, or do test here. This table shows we have used it. Now we have set this notebook to test the model's performance, so we have set the do train as a false. Here I need to, yeah, this we have used the pre-trained BERT, and here because our language is the Dart language, so we have used this multi-language pre-trained BERT. But if you will use other languages, you can also use this one, but you can also use the trained model, the model that trained of that specific language. Here we set all those hyperparameter, and here we show the samples from the JSON data. That's the organize of the tensor. We can say that the token is composed by those different parts: the image start token, image end token, the sentence. This used to record the PI data's information, and the image tensor. The image tensor contains all those 3 image modalities features. And also the last one is the label tensor. It also contains 6 tensors, because we have 6 indexes to be regressed. Here is how we evaluate the model's performance. We have used the RM's mean square error, R value, and the mean absolute error. Also, this one shows how we generate the density scatter figure. Here we have defined the train function, and okay, and the evaluation function. Here's the part how we evaluate the model's performance on different domain, on different livability indexes. We have calculated both the RMSE, RMSE, R square, Pearson R, and on overall livability, physical domain, nuisance and insecurity, social coherence, amenities, and housing availability. Here is the part that we train the model, and here is the what that we have evaluated the model and generated the density scatter plot. And this is the output of the evaluation result. We have finally saved the evaluation result. And for the code that using other modality combination, we first need to change the the name of the train validation and test file. Because this one is the one that only using the RS images, so we have set all the PY test part as none, so to ensure there's no input of the text information. And we also changed this part. We have rewrite the MMBTUTils file to let it only input the satellite imageries tensor to the model, features to the model. Others part are similar. So let's go to this one. Here, we at the beginning of this notebook, we need to copy the attention tensor here because the attention tensor is really huge. So I have deleted it here. And then those tensor will be calculated, will be, how to say? Yeah, it will be summarized in different dimensions. And this one is the result that when we can say that RS, yeah, for each modalities, especially for each image modalities, it will generated. Yeah, I mean we know that for the transformer, we have used has 12 heads, and for each heads, at this stage, each modalities will generate three tensors. We summarized those, and then we have summarized the upper, middle, and the lower tensors together, and to get this one, to get an overall attention that the model given to different modalities on different head. And finally, we have calculated the overall attention that the model given on all those 12 heads and calculated this one. So that's how we calculated the attention. Okay. Yes, that's all. Any questions?
Hi, Wen. I
Yeah.
have a question. Yeah, my name is Xingu, and I'm a postdoc at the Texas State University.
Mm-hmm.
My question might be a little bit far away from the topic that you are developing
Mm-hmm.
new deep learning, transformer-based deep learning method. My question is, so when you say the assess the livability of the community in a city, and
Mm-hmm.
I just put that question in the chat GPT, and
Mm-hmm.
then they give me an answer, and then I ask chat GPT to give me a rank, and then I got the rank for the factors that could affect the livability of the city.
Mm-hmm.
The first com the first three are the first is the safety. The second is housing, just as you have the factor in your model, and
Mm-hmm.
the third is the accessibility to the healthcare, which is health and well-being.
Mm-hmm.
So my question is, uh, since you have the housing factor included in your model, so have you have any source to consider other factors like safety or access to healthcare, mobility, like the access to the work, education, and some other factors into your model? Thank you.
Yes, that's a good question. In fact, we can also say that our ground truth comes from the Dutch government. So they have already using the statistic methods way to calculate the livability for different domains. And then based on those domain livabilities, they generated the overall livability. While when they generate the overall livability, the process is not only simply get the average of those 5 domain livabilities, but given different domain livability are different ways to generate this one. And so when we evaluate the livability, we have also evaluated the 3 parts that you have mentioned. And also the next questions is about how about other factors, right? Yes. I can show you this table. In this research, we have not used the detailed indicators directly, but we do believe that those types of information contains in the geospatial data. For example, I forgot the safety, like the safety and housing. For the second one and the fourth one, we can say that some research shows that night light satellite imageries can reflect the nuisance and safety, like maybe for the area with much, especially at night, those area with lights are much more safe than those area without lights, right? So there's
I'm sorry. I'm
yeah.
sorry. So you say when you use the satellite imagery data, the brighter the light, the more safer a place. Is that the
Uh,
argument?
that's not only, I mean, it's just a simple aspect because this research has already shows that using the night light satellite imageries can reflect the nuisance and safety. So we have, according to our reference work, we have used these modalities to evaluate this domain. And yeah, one very simple phenomenon is usually for those areas without light during night, it's much more dangerous. Yes,
So
and
you say
also
there is more bright, more dark of a place is gonna be more dangerous
yes,
during the nighttime.
sometimes. Yeah,
Okay. Yeah, yeah. Typically, the night light imagery data is a reflector of the economic status, and is more associated with the point of interest. And then, according to the criminology theory, the more the PUIs, the more likely to occur crime. So yeah, there's a link, but seems like it's different, a little bit different from the assumption here, but it's fine. Yeah.
yeah. You have asked a really interesting work, but we can go to this one. We can also say that even for the night light imageries, I think it's this one. I forgot which one. Yeah, even for the same modalities, it can give a different contribution to different modalities. Like when we analyze the nuisance and the insecurity, right?
Mm-hmm.
We found that the PUI, yes, the PUI can provide the highest information gain. It means it's also aligned with your points, right? For the safety situation, the PUI also contributes, I mean, provide much more information than other modalities on the nuisance and security. So I agree with your points. But we can also say that for the night light imageries, it's just followed by the PUI. It also contributes a lot. And while for this nuisance and security, the remote sensing imageries, it gives less information gain.
So have you got a chance to check the VIF score between the light image and PY, the number of PYs?
Yes, I have calculated this, but haven't shown in this slide. I think, let me check my paper. Maybe almost all the grid contains PY data, but with different number of PY.
That's fine. Thank you for
Yeah,
your
sorry,
answer.
I
Yeah,
cannot. It's not.
we can discuss in the future if we have a chance.
Yes,
Yeah, thank you. That's
yes,
fine.
we will. Thank you.
Thank you.
Any other question? It seems no more questions.
Yeah, if there are no more questions, I guess we can end it here. This recording will be available online in a couple weeks. Then obviously these resources will be available as soon as this paper is accepted. So keep an eye out for both of those. And again, hope to see you at the iGuide forum or at any other VCOs. Thank you for attending, though. We'll hang out for just a
Thank
couple more
you.
minutes in case you have any questions.
Yeah.
The videos will be posted on the iGuide website under the VCO tab. There's usually a little bit of a lag because we just have to get them edited, but they usually take 2 to 3 weeks, and then they should be up under the past sessions. It'll say like recording available when it's available. There aren't any other questions. I think we're gonna head out. Thank you all again for coming. And
Thank
thank you,
you.
Wen, for the presentation.
Thank you for your invitation.
Yeah.